Good day, and hi! We extend our warmest greetings as we present our video proposal on the transformation of the Faculty of Sports Science and Recreation into a green building at UiTM. We express our gratitude to the organizers for providing us with this valuable opportunity. We are thrilled to present our proposal, which centers around greening the infrastructure and operations of the Faculty of Sports Science and Recreation. People believe that greening a building is expensive, just a trend and non-access to materials. However, this misconception does not hold true as the reality of green building solutions proves otherwise. Our presentation focuses on the Faculty of Sports Science and Recreation at UiTM. To date, no assessment has been conducted to evaluate the building's sustainability. We undertook a comprehensive analysis to gain insights into its current environmental status. Our study aligns with established green building standards in Malaysia, such as GBI, MICREST, and Greenery, which emphasize key aspects of environmental sustainability. To begin, we would like to address the issues we have identified using green rating tools as a reference. These issues are categorized into physical concerns, energy efficiency, water efficiency, site planning and management, material resources, innovation, and indoor air quality. Our analysis found several green issues at the FIR building in terms of energy efficiency issues. We noticed that most of the hallways at the FIR building were lighted during the daytime because of the absence of natural lighting. The air conditioners and lamps were switched on in several classes even though when no one were using the class. Moreover, some of the lamps, as well as spotlights, were broken and they are not being replaced. Most of the gym equipment used high usage of electricity. All the existing lighting systems used were non-energy efficient lighting systems. Adding to this, the air conditioners used are central air conditioning, which is known to be outdated technology nowadays. It needs more maintenance compared to updated models. Next is indoor environmental quality. It is important to have good airflow and a sense of space in a building. Inadequate ventilation and air filtration as well as ignorance of the usage of natural ventilation in a building may lead to several issues. Over-reliance on air conditioning, thermal discomfort and physical discomfort are the issues that arise if good ventilation systems and air filtration are absent. Other than that, the choices of wall paints being used have lessened the sense of space and aesthetic values of the building. Next is water efficiency. During our site visit to the faculty, we discovered a number of problems that hinder the facility's ability to operate efficiently and promote sustainable water consumption. For instance, we discovered an impromptu water recycling system that is visible from the exterior, as well as the use of inefficient sanitary fittings in the restroom and using a direct water supply system. Next is site planning and management. We discovered that the building is lack of shading due to the direct radiation from sunlight penetrates the building, leading to a substantial rise in internal temperature. Next, we found an issue about the usage of chemical-based pest control that could cause contamination of the surrounding area and health issue. Then we also found that there is lack of green parking space as well as the charging infrastructure and the parking spots available are limited. Next is material and resources. The current insufficiency of recycling facilities provided by FIR leads to a significant carbon footprint, discouraging recycling among users and resulting in increased waste and pollution. Besides, the Faculty of Sports Sciences and Recreation FIR faces a pressing issue of a cluttered and disorganized environment due to improper storage of unused materials, posing potential risks and hazards for students and faculty members. Under the GBI element, which is innovation, we found few issues including no advanced air filtration technology and poor building's exterior appearance. Without cutting-edge air filtration equipment, indoor air quality might be subpar, putting building inhabitants at risk for health issue. Not only that, during the site visit, the building's exterior was covered in dirt, and the paint appeared to have worn away. To solve the energy efficiency issues in FIR, we proposed to upgrade the appliance used into an energy-efficient appliance. For instance, All the lighting systems can be changed into motion-activated LED lighting systems. Other than that, the installation of piezoelectricity, solar panel and energy-generating gym equipment was suggested as approaches to reduce electricity consumption and can generate more energy. We addressed some approaches that can be made to increase indoor environmental quality in FIR. The indoor plants can be used as natural air purifiers to improve indoor air quality and regulate humidity, resulting in thermal comfort improvement. The same goes for proper ventilation installation. Adding to this, building automation systems such as smart thermostats and occupancy sensors can be utilized to help optimize HVAC system operation. Furthermore, the installation of green roofs and the usage of sound-absorbing materials in a building can lessen noise pollution and act as insulation. Changing the color wisely can increase the sense of space and aesthetic values of a building. For example, it is suggested to use lighter and soft colors to look more spacious. To promote water efficiency, we suggest replacing the unplanned water recycling system with a proper and effective water recycling system, reconfiguration of plumbing system to incorporate rainwater harvesting system, and also upgrade sanitary fittings to efficient sanitary fittings. Next, we proposed the best ways regarding the site planning and management issues, which including vertical greenery wall, pest repellent planting, and green vehicle parking space. Vertical greenery wall and pest repellent planting have the benefits of controlling temperatures and also work as a natural pest control. Hence, lawn grid parking can contribute to reduce heat island effects and better drainage parking spots. Material and resources focuses on strategically placing recycling bins and donation bins in convenient locations campus-wide. Implementation of anaerobic digestion or composting methods within the FIR to recycle organic waste, reduce landfill waste, and decrease greenhouse gas emissions. Our proposal also suggests establishing easily accessible storage spaces throughout the building. These designated storage areas will be clearly marked with signage and labeling to ensure proper organization. The best ways to counter the issues regarding innovation, we suggest that the buildings are installed with HEPA filters and also self-cleaning glass. HEPA filters can remove allergens, bacteria and viruses as tiny as 0.3 microns, which is very useful for the occupants. The total cost of the proposed project is estimated at RM18648 to 6.01, with each element allocated a specific budget. Our company propose obtaining the cost data for the project through two methods. Firstly, we will gather quotations from contractors and suppliers, as well as update the tender price index TPI using data from previous projects, which is a 2021 projects that located in Paranganu. To illustrate, we have obtained quotations from specialist contractors for the solar panels and rainwater harvesting system. Additionally, for the LED lights and motion sensing, we have utilized cost data from previous projects, adjusting them for factors such as the cost index, location index, and price index. It is important to note that we have accounted for additional costs of 5%, with 1.5% allocated for both profit and attendance for all items. Next is life cycle costing, that describes a comprehensive evaluation and estimation of all costs related to a project or initiative from the beginning to its completion. This includes a thorough evaluation of all cost elements, including labor, supplies, machinery, technology, overheads, and any potential risks. We have also done the cost-benefit analysis. CBA can assist in determining the economic viability and environmental impact of incorporating sustainable practices and technologies into the design of a faculty sports science and recreation building. When using a green approach, for this presentation we have chosen 3 elements for showing off the CBA. Example: the solar panel, appliances, and certain room will be powered by the electricity produced by solar panels. The facility can offset some of its grid-supplied electricity use with solar energy, which will result in lower electricity costs. The size of the solar installation, the cost of electricity in the area, and how much energy is used by the building all affect how much money can be saved. Next, LED lights with motion sensor that only activate when motion is detected, and they automatically turn off when no movement is detected for a specified period. Only activate when motion is detected, and they automatically turn off when no movement is detected for a specified period. This feature eliminates the need for lights to remain on constantly, leading to significant energy savings. Compared to traditional lighting options, LED lights consume less electricity, resulting in lower energy bills over time. They also reduced maintenance and replacement costs since LED lights have a longer lifespan compared to traditional incandescent or fluorescent lights. For the water harvesting system, reducing reliance on costly municipal water and resulting in reduced water bills. Maintenance costs are lower than those of alternative water systems. For modular vertical garden, protects the building's exterior from rain, wind, and UV radiation. Reducing exterior repairs, repainting, and refinishing saves money. It will absorbs and disperses outside sound, creating a natural sound barrier. It will also give thermal insulation, reduces heat transfer throughout a modular vertical garden. This reduces heating and cooling needs and helps regulate indoor temperatures. The application of sustainable building elements in the Faculty of Sports Science complex at University Technology Mara is to clearly articulate the objectives of sustainable building, which include the reduction of energy consumption, as well as promoting energy efficiency in the building, ensuring a healthy and comfortable indoor environment for occupants, promoting the use of sustainable materials and minimizing resource consumption, minimizing the environmental impact of the site, enhancing ecological integrity, and promoting resource efficiency. Thank you.